Alright, honors, in this video we finished concept 53. First thing I want to start with is you can pause the video so that you can start filling in the values in your unit circle in case you didn't do so at the end of the last video. So I want to start by reviewing, right? If you remember what I said at the end, I said all you really need to know is the first quadrant, right? The values of the first quadrant of our trig values, and then from there, if you understand how the quadrants work, your positive signs, negative x is positive y's, negative x is negative y's, positive x is negative y's. If you understand how the quadrant signs work, then all you need to know is the first quadrant, and you can figure out all the rest. Down here, I had some students ask, what's this table asking for? It's the signs of each trig function relative to the quadrant that we're talking about. So quadrant 1, all the signs here are positive, right? Half, square root of 2 over 2, square root of 3 over 2. Those are all positive here. For quadrant 2, you can see that all the signs are positive. The sign values are positive. So it's quadrant 2 is positive. In quadrant 3, we're now in the negative y-axis, and then you can see that my sign values here are negative. Whoops, negative here. Okay, so then quadrant 3 sign is negative, and then quadrant 4, you're still in the negative y-axis, and all my sign values here are still negative. Whoops, right here, negative. So cosine works the same way. Positive here, negative here. So I have positive, negative. Quadrant 3, right here, still negative, right? So negative here. And then quadrant 4, these are all now positive. So I have positive here. Tangent theta, right? These would be you would have y over x, right? So if you took sine over cosine, so half over square root of 3 over 2, what would be the sign of those values? Well, positive over positive, positive over positive, positive over positive. Those are all going to be positive. So in the first quadrant, you have positive. Here, now my x would be negative. So your numerator, your signs, would be positive, but you'd be dividing by a negative. So then the overall sign there is going to be negative. Quadrant 3, these are both right here, these are both going to be negative values. So if you have sine over cosine, negative over negative becomes positive. And then finally, tangent, fourth quadrant for tangent, these are, your signs are negative, but your cosines are positive, but negative over positive is still going to be negative. Okay, so that's what these tables down here were asking for, and then fill in your unit circle as you need. So the next page does just that. It's asking for just that. So let me fix this. It says which trig functions are positive in, and then it's asking for the quadrants, and you can use the little table we just said, but of course it works the same way as any coordinate point. That you guys can see that here. Okay, and this is a neat little mnemonic device that will help you remember just the order in which the quadrants go. All students take calculus. All students tangent take cosine calculus. So all students take calculus. That's one way to remember as you go about trying to remember the signs. Okay, the next part, we have a couple questions. Let's see. Cover this first. It says, if tangent theta is greater than 0, which quadrants could the terminal side of theta lie? So you have to think. Tangent theta is positive. So I'm not sure if I'm going to be able to fit the entire thing here. So you look at your values here, okay, all around the unit circle, and you have to think, okay, in which ones is tangent going to be positive in, right? Because tangent is greater than 0, which means it has to be positive. Well, quadrant 1, right, sine over cosine, these are positive values, you're going to get positive. Here you get negative. Here, quadrant 4, one of them is negative, so tangent is negative. But then here in quadrant 3, they're both negative, so you're going to get a positive. So we're talking about quadrant 1 and quadrant 3. These are where tangent is positive. Therefore, if you have, if you're representing tangent theta, the terminal side of theta has to lie in these two quadrants, because this is where tangent is going to be positive. It's going to be negative in quadrant 2 and quadrant 4. So then that's going to be your answer for there. Q meaning quadrant, so quadrant 1 or quadrant 3. Number 2 says, if secant theta is less than 0, which quadrant could the terminal side of theta lie? You have to remember that secant is the reciprocal of cosine. So you can also say, right, because we have secant cosine theta is equal to 1 over secant, right? So then if you can rewrite this so that secant theta is equal to 1 over cosine theta. Okay, there. That's what I have here. So in which quadrants is secant theta less than 0? So we're talking about negative cosine values. Those are less than 0, right? So right here, cosine is positive. Here, cosine is negative. Okay, so these are less than 0, so we have quadrant 2. Here, these are still negative, so cosine is negative. Therefore, if you take the reciprocal of both of these, the ones in quadrant 3 and the ones in quadrant 4, secant will also still be negative. And then right here, cosine is positive, so I can't use quadrant 4. So then the only two quadrants I can use are quadrant 2 and quadrant 3. The next one, says, if sine theta is greater than 0, which quadrants could the terminal side of theta lie on? So we want positive sine values. Here's sine positive. Here's sine also positive, quadrant 1 and quadrant 2. Quadrant 4, you can see that sine is now negative, and then of course quadrant 3, sine is also negative. So you can't use those. So it's quadrant 1 or quadrant 2. Number 4 says, if cosine theta, this might be the more difficult one, okay, if cosine theta is less than 0 and cotangent theta is greater than 0, which quadrants could the terminal side of theta lie? So it has two requirements. So looking at my unit circle here, cotangent again is sine over theta, so then cotangent is going to be cosine over sine. But you want it to be positive. They want it to be positive, so you're going to have to take either a positive over a positive or a negative over a negative. So I can use quadrant 2 and I can't use quadrant 4 because one is positive, one is negative. That'll give you a negative. Here they're both positive, so I'm using quadrant 1. Quadrant 3, they're both negative, so it'll give me a positive. So for cotangent greater than 0, I'm using quadrant 1 and I'm using quadrant 3. For cosine theta less than 0, you're going to be using all the negative cosine. So negative cosine, we already know it's going to be quadrant 2 and quadrant 3. So what's the overlap? We said cotangent was 1 and 3. Cosine is 2 and 3. So the requirements, the double requirement is met in quadrant 3 here. So the terminal side of theta has to lie in quadrant 3. Okay, and that's what I have written here. The quadrants for each of them in which the rule holds, so that the overlap is quadrant 3. Okay, so the next one, the next section says, let me see, it says using, and I'm reading off the side here, it says using reference angles to find trig values. So, and this again, this further reinforces the point I made. You just need to really know the first quadrant, and then from there you'd be able to find all the rest. It says find the measure of the reference angle. Okay, that's will be your first step, and then you're going to identify the trig function for that reference angle, and then you adjust the sign if needed, because again, if you know the first quadrant really well, you know them all. Okay, so it says give the exact value for each trigonometric function. So for the first one, I'll just go ahead and show you guys the entire row, right? But I'll explain as I go. It says Sine of 150. Okay, so the reference angle to 150 is going to be 30 degrees. Why? Because, well, if you open up to here 150 degrees, this here would be your reference angle. Okay, now remember how I explained that all these angles, thanks to the reference angles, they're all in a sense similar. All that changes is their sign. Sine of 150, the reference angle is 30 degrees. We just shown that. So then we're talking pretty much sine of 30, just in a different quadrant. Okay, 150 degrees lands in the second quadrant. So does the sign of your does the sign of your sine change? Right? No, it doesn't. They are still positive. So the only thing that changes is the cosine value. So it's a half here and a half here. So therefore the sine of 150 is 1/2. Tangent 300. Tangent 300 degrees is in the fourth quadrant, right? Now the reference angle for 300 will be 60 degrees. So we're pretty much talking the same idea of tangent 60, which is right here, but we just need to keep in mind we're in the fourth quadrant, which means my y values, or my sine value, is negative. So you have negative square root of 3 over 2 over 1/2, right? And that makes sense here because that's the point on 300. So you would do this over this, and then you would simplify, and then you would get negative square root of 3. Number 7, I have cosine of 225. 225 degrees lies in the third quadrant right here. The reference angle for 225 degrees is 45 degrees. So we're pretty much looking at cosine 45 just in the third quadrant, where cosine is negative. So then the cosine of 225 is going to be negative square root of 2 over 2. The next one, I have cotangent of 315. So 315 lies in the fourth quadrant right here. 315, this is the reference angle here, is going to be 45 degrees. So we're talking cotangent of 45. Cotangent of 45 is cosine over sine, right? It's the reciprocal of tangent. So, but it's all the same here, right? It's all the same. But cotangent of 315 is in the fourth quadrant where y is negative. So this over this is just going to give you negative 1. Okay. Tangent of 240 degrees, the reference angle, those are the values I have here written, by the way. I don't think I made that specific. So tangent of 240 degrees, here's 240. The reference angle is going to be, sorry if you could hear that car. Okay, so tangent of 240 degrees, the reference angle is going to be here, 60 degrees. Okay, that's what I have here. I'm in the third quadrant where they're both negative, so I'm going to have this over this, and you would simplify, and then negative over negative is going to get positive, so you're going to get positive square root of 3. Number 10, I have secant of 300 degrees. 300 degrees is right here, is in the fourth quadrant, and secant is the reciprocal of cosine. So right here, okay, 1/2. And the reference angle of 300, again, it's 60 degrees. So we're pretty much looking at this one here, except well, you're in the fourth quadrant where cosine is still positive, so it doesn't change. So you just take the reciprocal of this and you get 2. 2 more rows. But now we have radian measure, but it still works the same way, okay? Cosine of 11 pi over 6. So 11 pi over 6, I have that right here. Okay, it's in the fourth quadrant. So my reference angle is going to be pi over 6. So we're looking at cosine here. Now I'm in the positive x-axis, so the sine of radical 3 over 2 stays the same. So that's basically all I'm looking at. So it's radical 3 over 2. Cosecant, this is the reciprocal of sine, okay, 7 pi over 4. 7 pi over 4 is in the fourth quadrant. It's right here. Okay, so I forgot already. Yeah, we're talking cosecant. So this is the reciprocal of sine. So here's sine 315. The reference angle is again 45. So we're talking this here, right? And then sorry, 45 degrees. So my sine of 45 is here. Cosecant would be the reciprocal, so then you would flip these, and then again you can't have a root in the bottom. You would simplify whatever you get, and then when you work that out, you're going to get negative square root of 2. Okay. Oh, and I forgot to mention 7 pi over 4, that was in the fourth quadrant where sine is negative, so that's why my answer is negative. Here, right, the reference angle would say positive, but I'm in the fourth quadrant, so it'll be negative. So that's why it's negative square root of 2. Sine of 4 pi over 3. 4 pi over 3, I am right here. Okay, I'm in the third quadrant. Sine is negative 3 over 2. And yeah, they're not asking for any reciprocal, so it's just this value here. But again, the reference angle would have been 60 degrees. So we are looking at this one here, but we're in the third quadrant, so it'll be negative of this one, and that's that one here. Last row, number 14, I have tangent of 3 pi over 4. So 3 pi over 4 is here, it's in the second quadrant. So you would have again, tangent is sine over cosine, so this over this. But the reference angle again is 45 degrees, so we're looking at this. So it's this over this, except your x is negative, right? Just like you have it here. So your answer is negative, and you should get negative 1 because they're both the same. Number 15, I have sine of 7 pi over 6. Sine of 7 pi over 6. 7 pi over 6 is going to be here. Where is it? Right here. 7 pi over 6 is right here. So the reference angle is this one right here, or pi over 6. So this guy here. But you're in the, again, third quadrant where your x and y are negative, so both of these guys are negative, and we're looking for sine, so it's just the negative of this guy, so negative 1/2. Finally, the last one is a secant of pi over 2. So secant is the reciprocal of cosine. Secant of pi over 2 right here. Okay. Cosine would be 0 over 1, which is why you get, whoops, right here, 0 over 1, which is why you get 0. So therefore, secant, you would take the reciprocal of this guy, of this point, and you're going to get 1 over 0. And of course, you can't divide by 0, so it's undefined. Okay, and that wraps up this concept. Just a reminder, I would use reference angles to jump from each quadrant to show you just how the signs change, because the goal that we're aiming for is that you can do these problems without needing the unit circle. Okay, so hopefully you understood that, and ask me questions if you need them.